Hello everyone, and welcome to this Desmos debrief. I know over the course of a semester we cover a lot of different things, a lot of topics, a lot of different technologies and formulas and things that you have to remember in order to complete them successfully. So I wanted to just go through really quickly some of the main highlights of things that you need to be able to do in Desmos in case you've forgotten them or you don't want to have to look through every single lecture video to find where we did something. Just make this a kind of a one-stop shop for Desmos for your needs in statistics. So you can see on the left-hand side here, I have created a couple of data sets, just random 6-element data sets. So first, I want to look at how to do kind of some of our standard functions on these data sets. So if you wanted to do mean, median, standard deviation, variance, all of that kind of stuff, they're pretty straightforward. You just put in the name that you're looking for. So for mean, you just type mean, and then you have to determine what data set you want to do this for. So that would be mean of A, and you get 5.833, etc. You could do mean of B and get the mean is approximately 14. If you want to switch it to a fraction, Desmos can do that as well. So you just click on this little fraction button over here, and Desmos can switch that back and forth. So the mean is pretty straightforward. If you want to do something like the standard deviation, so we're not going to type the entire words, but we would do STDEV, so STDEV, I guess, for standard deviation, and then select the data set. So standard deviation for A and for B. The variance, we could do this one by hand if we wanted to, but we don't even need to, just VAR for variance. We get the answers for those two. So mean, median, standard deviation, and variance, all pretty straightforward in Desmos. If you want to create, say, like a histogram in Desmos, you literally just type histogram, and then you would determine the data set that you want to do the histogram with. That would be, so say set A, and you can see Desmos has already created the histogram for me with kind of its regular specifications. So this next term over here, this bin width, Desmos is going to assume that you want it to be 1 unless you tell it otherwise. So I can change it to 2 or 3 or 4, and you can start to see the histogram changing a little bit. You don't want to make it too big because then you end up kind of losing a lot of your data sets and they kind of don't show up as well, but it will automatically set to 1. You can align it at center or at left, depending on if that helps visualize your data better. You can also change it to some different values, but typically we'll stick with the counts. You can, of course, change colors if you want, change color of your histogram, but this is what you need. So same thing, I can do it with like B, and you get histograms a little more spread out. So maybe I would want a bin width, say, of like 5, or maybe make that left centered there, maybe 6. So you can kind of play around with these different ideas and see how to do things like histograms. That's a very important part of data analysis. If we want to do something like the 5-number summary or a box plot, the 5-number summary, there is no one button that gives you all 5 numbers, but if you think back to what those are, it's the min, the max, and then quartiles 1, 2, and 3. The quartile number 2 is just the median. And the median is just type in the word median of A, for example, and we get 5.5. Do it for B, you get 15. But if you wanted to find like the minimum, you just type min of A, it'll give you that. Min of B, give you that. If you want to find the max, just type max of A, it'll give you that. So in case maybe your data isn't in order, it will still tell you what those min or maximum values are, so you don't have to go in by hand and figure out what they are. And then for the quartiles, you're going to type quartile and then parentheses, and then you're going to choose the data set. so say like A, but you also need to specify which quartile it is. And this is one thing that I really like about Desmos is if you type this and you're not sure, like what else do I need to put here, if you look over, you can see this little caution sign, and it can give you at least a hint of what you need to put. So let me get rid of my comma there. And you can see it tells us function quartile requires 2 arguments. For example, you can try quartile with a data set 1, 2, 3, comma 1. So the 1, 2, 3 is the data set, and the 1 would be the quartile. So I have data set A, and quartile 1 would be 3. If I want quartile 2, that's the median, 5.5, just like we saw earlier. If I want quartile 3, that's 9. If you want to get like the maximum, for example, we can call that quartile 4 if you want to think about it that way, and that'll give you the max. If you want the min, just put 0. So you can use the quartile function to do a lot of this stuff. If you wanted to create a box plot, just type the word box plot, and you're going to get something like this. So you can see here, it's got all the values in here, it's got all the quartiles, everything that we need. You can change where it's positioned in Desmos if you want, but you don't need to worry too much about that. Say that I inserted an outlier into this set, so like 25, for example. It's going to set aside that outlier out here so that you can determine that that is in fact an outlier. Makes it really helpful to just confirm if we suspect that something is an outlier. If you don't care about outliers, you can exclude them and just have a very, very extended box plot like that. So let me get rid of that. All right. So those are box plots. So handle very similarly to like histograms. And you can, again, you can change the color if you want. You can change how tall it is if you like. If you're doing something where you need to include an image of, say, a histogram or a box plot or something like that, you can play around with different settings on this. So you can zoom in. You can adjust the X and Y axes if you want to try to focus more on one particular shape. So say I wanted just to go from -1 to 2 on the y-axis. That gives us a clearer picture of the box plot. Maybe I don't want the grid on there, so I can keep the scale, but maybe I don't want the grid because it's too distracting. I can do that. I can bolden everything to make it appear larger if I like. This is really helpful if you're giving like a presentation. And then if you have an account on Desmos, which is 100% free, you just put your email, you can share your graph, and you can export the image. And this is something that's very helpful if you have to, create a visual representation for a report or your project, or just anything in general. You can just save it as an image and then just drag it into any file or any document that you need to. So that can be a very, very helpful tool. So if you want to reset your frame, just go to this little house button, so the default zoom button, and that'll set us back around the origin. Okay, so that is the box plot. The distributions, we did a lot of these throughout the semester. So if you want to do things like a normal distribution, you would do normal dist. And if you type nothing in the parentheses, it's going to assume that you mean the standard normal with a mean of 0 and a standard deviation of 1. If you want to change that, if you have a data set that is not the standard normal, you can easily change it. Just make, the mean is 4, the standard deviation is 3, or something like that. You can see it's a much flatter curve centered around 4. If I make my standard deviation smaller, like 0.5, you can see it makes the curve steeper over here. But if you put nothing, it'll keep it as the standard normal, which can be very helpful because that's the one that we use the most frequently with like z-scores and things like that. If you need to find a cumulative probability, you click that check mark. And if you know your minimum or your maximum, you can input those there. So say I'm looking for the probability that a value is less than 1.75. I would type my max as 1.75. And if I zoom in here, you can see It's the shaded area is what we're looking for, and that probability would be 0.9599. Okay, so around 96%. You can do that as a minimum or as a maximum, right? I can find anything I want in here, so I can narrow it down to a much more specific area. So that can be very helpful. If, on the other hand, if you know the probability, you know the area, and you're trying to find the z-score, you can, instead of using this cumulative probability, you would type a period and then inverse CDF, and then the number that's going to go in there is going to be the area under the normal curve to the left. So, for example, if we had a situation where we have our alpha value is 0.05, so on a normal curve, so if I do, just for visual purposes, just a regular normal curve, if alpha is 0.05, then we're looking at, well, I had that pretty close. So somewhere around here. So if we know that this whole area is 0.95, and we're trying to find what z-score accompanies that, in the inverse CDF here, you would put 0.95. And this number is the z-score that corresponds to this area. So if I did my maximum as 1.64485, something like that, you can see we're getting closer and closer to 0.95 here. Okay, and that would be the area to the left, would be 0.95. The area to the right would be the alpha value of 0.05. That's this little blank area over here. Okay, and if you have a different alpha value, you can do 0.90, something like that. If you have a smaller alpha, you can do 0.975, something like that. But this period inverse CDF is very helpful in finding the z-scores on a normal distribution. Additionally, you can do a t-distribution. So you do t-dist like this, and then all we need is the degrees of freedom. So if I know I have 4 degrees of freedom, there is my t-distribution. I can do min and max, cumulative probabilities. I can do the inverse CDF, all the same things that we could do with normal distribution. And then same thing, we can do a binomial dist, so binomial distribution. And for binomial, because these are discrete, you need to put the number of trials. So say we did an experiment with 10 trials, and the probability of success, say we flipped a coin. So the probability of success is 0.5 each time. If we look at the binomial distribution, and let me go ahead and adjust my axes, make this even closer. So you can see the points right here on this binomial distribution. And if you want to find the cumulative probabilities, it will draw these lines here. And this gives you the value at each one. So this is the probability that is associated with each outcome. We're going from 0 to 10 here. So if you want to find the cumulative probability, like what is the probability of getting between 2 successes and 5 successes? And then you would see here the probability is 0.61 approximately, and it highlights exactly which ones we are specifically looking at. So it's very helpful for binomial distributions as well. So you can use this for all sorts of different distributions, whether it be a normal distribution, t-distribution, binomial. They all will work for this. And then we want to look at scatter plots. So if you want to create a scatter plot of data, you would need to create a table. So you'd go up to this plus up here, add an item, and go to the table. And then it's going to give you 2 columns here. So I'm going to go ahead and just use A and B. So that would be 1, 3, 4, 7, 9, 11. And then I'll use B, so the corresponding values are 2, 6, 13, 17, 23, and 24. And you can see that in the table, it has plotted all of these points on the graph. So we can utilize this in creating a scatter plot. We can also find our linear regression line. The way that we do this is we basically construct the equation of a line using these y and x values. So we're going to do y sub 1. And then instead of an equals, we're going to use the little tilde symbol. So the little squiggle on your keyboard there. And then the formula for a line is y equals mx plus b. So we're going to do mx sub 1 plus b. And then it will give us any additional parameters that we need for the line of best squares. It will also plot residuals for us. So in this case, there's not a lot of variability here. Let me see if I can do something with this. Try to make this a little more exciting. And say 32. Something like that. So here we have our original points, which you can change the size of the points. You can draw lines between points. You can drag points if you want to kind of play around with it a little bit. You can change what they look like, all the aesthetic stuff. But then you can also look at the residual plots over here. Okay, so it tells you above or below that value. And then you can get the r squared value. You can get the m value, so that slope of it. That'll give you some information. And then you can also get the correlation coefficient as well, which is very important. And all you need to do is do CORR. And you can choose whichever data set you want to look at correlation for. And if you're not sure, you can see here it's looking for 2 data sets for you to correlate to each other. So for example, for set A and set B, if I do the correlation between A and B, you can see that there is about a 97% correlation between the two. So the two are very strongly correlated to each other. But this is an extra feature that can really help because the calculation by hand for the correlation coefficient is not something we want to do under any circumstances. So if you don't want to have to remember typing all of these different functions that we did here today, you don't have to remember them because you can just go into the keyboard, go into the Functions tab, and just scroll down a little bit here to Statistics. And you can see all the ones we did here. So mean, median, min, max, and quartile, standard deviation, correlation, coefficient, variance. You can see down a little bit further, we've got the histogram and the box plot. We've got the normal distribution, the t-distribution, and binomial. There's even inverse CDF down here. So they've got it all in here so that you can just click the button and not have to do any of the extra work. So you can see it'll just type it in there for me. And then you just put in whatever your data sets are that you want to correlate or you want to find the mean of, etc. So setting up data sets like this using the square brackets, that can be really helpful and save on a lot of work in the future. So this has just been a really quick rundown of a lot of the different things you can do in Desmos involving statistics and probabilities. There's so much more to explore if you go on further, but I think this is a great way to just kind of summarize all the stuff that you're going to need to know. So I hope this was helpful, and I will talk with you all soon.